All right, today we are diving into the Machine Learning with Python Cookbook to uncover a secret that's, well, hiding in plain sight. We're talking about the single most important part of pretty much all of AI and machine learning. So, when you hear the term machine learning, what's the first thing that pops into your head? Is it, those super complex algorithms with crazy names? Or maybe the giant, powerful computers you need to run them? Well, what if I told you the most critical piece of the whole puzzle is actually something a lot less glamorous? Yup, that's it. It's the boring, sometimes messy, and often tedious work of just preparing your data. It's not glamorous, but it is absolutely 100% vital. Before any of those cool algorithms can do their magic, your data has to be just right. I just love the way the source material puts it with this cookbook analogy. Think about it. Every great chef needs to master their knife skills, right? Long before they create some signature dish. Well, in the world of machine learning, our knife skills, that's data preparation. So let's start with the most fundamental tool in our kitchen. For a chef, it's the knife. For us, in Python, our knife for slicing and dicing data is a library called NumPy. It's what lets us represent all our information in a way a computer can actually understand. Now, the main thing we're going to be working with is called a matrix. And hey, don't let the name intimidate you. It's really just a grid of numbers. Seriously, think of a spreadsheet. That's the basic idea. This is how machines see the world we're trying to show them. And we start with the simplest form possible, a vector. It's just one row or one column of numbers. And this could represent anything, really. The temperature for 3 days in a row, a stock price over 3 hours, a student's scores on 3 tests. It's like the basic atom of our data. And from there, it's pretty simple. We just stack those vectors on top of each other. And boom, just like that, we've got a matrix. Now, this two-dimensional grid can hold much richer information. Like, not just the test scores for one student, but the scores for multiple students. And once we have our matrix, we need to know what we're looking at, right? NumPy gives us these super simple tools to quickly check its shape, how many rows and columns it has, its total size, and how many dimensions it's working with. This is going to be your best friend, a quick gut check that you'll use constantly just to make sure your data looks the way you think it does. Okay, so we know how to structure data, but where does all this data actually come from? Well, that brings us to our next big step, the Great Data Roundup. For this part of the job, we bring in another total powerhouse of a library, pandas. If NumPy gives us those raw, super fast building blocks, you can think of pandas as the really friendly, powerful toolkit that's built right on top of it. It lets us load, manage, and start analyzing entire data sets with incredible ease. And I mean, it can get data from almost anywhere. It doesn't matter if your data is sitting in a simple CSV file, a big corporate SQL database, an Excel spreadsheet, or even a more modern format like Parquet. Chances are, Pandas has a function to read it. That versatility is exactly why it's such an essential tool. Okay, but what if you don't have a data set? You've just got an idea for an algorithm, and you want to play around with it. Do you really have to go spend hours searching for the perfect data? No way. You just make it up. Seriously, libraries like scikit-learn let you generate your own synthetic data with the exact properties you want. Like, check this out. These are clean, distinct blobs of data points. It's the perfect, clean sandbox to test out an idea like a clustering algorithm without all the messiness of a real-world dataset getting in the way. Okay, so we've got our data. We've either loaded it from a file or we made it ourselves. Now comes the main event. This is data wrangling. It's where the real work and, honestly, the real fun begins. This is where we clean and transform that raw, messy data into something truly useful. And to really get our hands dirty, we're going to use a classic data set, one that's actually featured in the cookbook, the passenger list from the Titanic. It's small enough that we can wrap our heads around it, but it's got some of those classic data cleaning challenges we need to solve. So let's look at a really common problem, inconsistent data. For an algorithm to work properly, it needs things to be recorded the exact same way every single time. So what do you do when your data lists gender in a bunch of different ways? How do we make it all uniform? Well, with a library like Pandas, it's actually incredibly simple. We can just tell it to find all those messy entries and replace them with a clean, standard one. I mean, look at this before and after. You're taking this jumbled list and making it perfectly uniform. It's just so satisfying, right? Now for one of my absolute favorite techniques, once the data is all clean, we can finally start asking it some interesting questions. And one of the most powerful ways to do that is to group rows together based on something they have in common, so we can uncover hidden patterns. The process, which is often called a group by operation, is like a simple three-step dance. First, you choose what to group by, let's say gender. Second, you pick what you want to measure, maybe age or survival rate. And third, you apply a calculation, like finding the average. And what you get back is pure insight. By grouping the Titanic data just by gender, we instantly find a really dramatic story. I mean, the average age was pretty similar between men and women, but look at that survival rate. 67% for women versus a shocking 17% for men. Wow, that one simple operation tells a huge story hidden in the data. So we've gone from the raw building blocks to loading data to wrangling it into shape. And all that hard work, all that foundational prep, it all leads to this moment. A single, clean dataset totally ready for a machine learning algorithm. And you really shouldn't underestimate how much effort this takes. A lot of data scientists will tell you that this whole process, the cleaning, the wrangling, the prep, can take up to 80% of their time on a project. Yeah, you heard that right. 80%. It is the bulk of the work. So look, if you take away just one thing from all of this, let it be this. A fancy algorithm fed messy data is only ever going to give you garbage results. But even a simple algorithm, when you feed it clean, well-structured data, can produce some incredible insights. At the end of the day, your machine learning model is only as good as your data. And that really just leaves us with one final thought. Once you've done all that hard work, once the data is pristine and ready to go, what story do you want it to tell? What question will you ask?